This video looks at angles of elevation and depression. Angles of depression and elevation are both measured from the horizontal. An angle of elevation is measured upwards from the horizontal. An angle of depression is measured downwards from the horizontal. Because alternate angles are equal, angles of elevation and depression are always equal. This angle and this angle in the diagram are equal. In this example, a lighthouse sits on the edge of a cliff. From the top of the lighthouse, 150 metres above sea level, a small boat is seen with an angle of depression 58 degrees. Our job is to find the distance that the boat is from the base of the cliff. We could draw ourselves a diagram. It might look something like this. The first thing we will notice is that it was the angle of depression that was given, 58 degrees. That's not inside a triangle at all. But the important thing to remember is that the angle of depression from the lighthouse looking down to the boat is the same as the angle of elevation from the boat looking up to the lighthouse. The angle at the bottom there is 58 degrees as well. If we redraw the triangle, it becomes a very simple trigonometry problem. The sides involved are opposite and adjacent, so this is a tan question. We can say the tan of 58 equals 150 divided by d. Multiply both sides by d. Divide both sides by the tan of 58, and we can get our calculator to work out that d is equal to 93.73 metres. A surveyor uses the theodolite to find that the angle of elevation to the top of a building is 45 degrees and 15 minutes. Find the height of the building given that the theodolite was 135.2 metres from the base of the building and the instrument was mounted on a tripod so that its height was 1.5 metres above the ground when the measurement was made. One of the first things that you need to notice in this question is that the angle was given in degrees and minutes. Degrees and minutes can be tricky to work with in a question, and it's often a good policy to change it into decimal degrees before you start the question. This one, if you've got a little converter on your calculator, you can change them and it'll change to be 45.25 degrees. Decimal degrees will add and subtract much better than degrees and minutes, and so they're much easier to use. If we draw a diagram for this question, it'll look something like this. Notice that the building's height is 1.5 metres higher than what you would expect if that theodolite wasn't involved in the question. The theodolite was 1.5 metres above the ground, and so the building's height is going to be 1.5 metres more than h. To find h is simple trigonometry. The question involves opposite and adjacent. That makes it a tan question. Tan of 45.25 is equal to h over 135.2. And from there, it's just a matter of simple transposition and a little bit of calculation to work out h. The total height of the building, though, we need to add on another 1.5 metres. Total height 137.88 metres. In this question, we had to consider the extra height of the theodolite because we were particularly told about it. But in most questions, where you have an observer involved, there's no need to consider the height of the observer unless you are particularly asked to.